Okay. So there are only 6 students, I think. Sumit Narayan Divedi and Amral Raj. Okay, I'm starting my presentation. Is it visible to everyone?
Yes, sir.
Okay. Okay, so today class is remote sensing image interpretation. Uh, so first of all, we have to discuss about the remote sensing. What is remote sensing and what is the different remote sensing ingredients are there. So remote sensing technique is generally the uh, acquiring information about the object from the distance with the help of electromagnetic radiations. So there are some techniques which are used for the remote sensing uh, process. So that is energy resources. So there is a need of energy resources, whether it is active or passive. So like sunlight, it is one of the important energy resources for remote sensing analysis. Then radiation and the atmosphere and interaction, then radiation and atmosphere, that means the atmosphere is the medium where we can use this medium as a energy transmission and energy radiations. Then interaction with target means here it is a different art objects like water and vegetations, buildings, river, road, and other features are there. So these are the targets in the form of objects. So with the help of this target, we can uh, create a image that is called remote sensing based image. So recording of energy of the sensor. So that is also one of the factor which is used in the remote sensing technique. Then transmission, reception, and processing unit. And after that, the interpretation analysis. After completing this transmission, reception, and processing, we use the interpretation analysis. Then after interpretation, we can use this data as a applications. Is it audible to all of you? Hello?
Yes, sir.
Okay. You are from?
From Gujarat, sir.
Okay.
Junagadh.
Okay, Junagadh. So you are comfortable with Hindi, English, or
Both, sir. No
okay?
issues.
Okay, okay. Then I will continue with both of these language. So what is the difference between GIS and remote sensing? So GIS generally use the uh, remote sensing टेक्नोलॉजी टू यूज ऑल दिस एप्लीकेशंस. तो हम क्या करते हैं कि डिफरेंट जो रिमोट सेंसिंग इज द बेसिक्स फॉर creation of different GIS applications. Suppose we have to create a land use land cover map. So we need a remote sensing based satellite image or aerial photograph or any other images. So which is acquired from the remote sensing technique. तो रिमोट सेंसिंग पहले तो हमको रिमोट सेंसिंग बेस्ड इंफॉर्मेशन कलेक्ट करना है, उसके बाद उसको प्रोसेसिंग करना है, उसके बाद उसका रेक्टिफिकेशन, आफ्टर दैट वी यूज इट इन द जीआईएस प्लेटफॉर्म इन डिफरेंट सॉफ्टवेयर. तो रिमोट सेंसिंग बेस्ड सॉफ्टवेयर डिफरेंट है एंड जीआईएस बेस्ड सॉफ्टवेयर डिफरेंट है. तो बेसिकली जीआईएस बेस्ड एप्लीकेशन इज used for different IT based softwares are there, and remote sensing is basically contributing in the field of mathematics, physics, and some electronics part. So these are the difference. So without remote sensing, there is no value of the GIS. देन ईएमआर, इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम. हम जनरली क्या करते हैं, जो रिमोट सेंसिंग टेक्निक हो या जीआईएस एप्लीकेशन, जितने भी सैटेलाइट इमेजेस हैं, तो द डिफरेंट थ्री वेरिएबल, उसका थ्री हमारा विजिबल रीजन्स है और माइक्रोवेव रीजन एंड इंफ्रारेड रीजन, तीन डिफरेंट डिफरेंट वेवलेंथ रीजन्स में हम डाटा कलेक्ट करते हैं. सो विजिबल रीजन, that is a true color satellite image. So generally use blue, green, red, ultraviolet, and infrared spectrums. So which ranges from the wavelength blue 0.5, 0.4 to 0.7 micrometer. So ये बहुत इम्पोर्टेंट थिंग है, क्योंकि इसको अभी एग्जाम में भी बहुत ज़्यादा आता है ये सब. So what is the visible region? Which spectrums are important for the visible regions? What is the infrared region? So after that, then microwave and infrared. So visible is the small wavelength. Then after that, infrared, it is greater than visible region. Then microwave region. So wavelength gradually increases from visible region to infrared region, then microwave region. So in the microwave region, the wavelength is very high, so it penetrates through the cloud. So in the flood analysis, we use the microwave-based satellites, and in infrared, generally we use the different vegetation index calculations, mangrove forest calculations, due to the high reflectance of the infrared region. Any question? हेलो, कुछ डाउट है तो पूछ लीजिए.
No, sir.
ओके. Then various platforms are there for the remote sensing technique, and that is aerial platform which is connected to the ground, then airborne platform, then spaceborne platform. In the aerial platform, generally it is range from 0 to 0.3 kilometers, and after that airborne platform it is 1 to 4 kilometers. Then space based platform, that is which is includes the different satellite images. So there is various satellite sensors are there. So there are two general orbits are there. That is geostationary orbit and polar orbit. So all of the Earth observation satellites like Landsat 1 to Landsat 8, 9, and Indian remote sensing satellites, IRS List 3, List 4 satellites, all are polar satellites. And geostationary satellites are, these are the weather forecasting satellites, INSAT, and weather forecasting, and that is telecommunication satellites. So energy source and the illumination, the first requirement for the remote sensing is to have an energy source which illuminates and provides electromagnetic energy to the target of the interest. So energy source basically coming from the sun, in the passive way and active way. The some satellites have their own illumination power, that is called I think micro satellite images are there. Then radiations in and the atmosphere. The energy travel from its source as a target. It will come into contact with the atmosphere and passes through this. This interaction may take place in second times as the energy travel from the target to the sensor. So interaction with targets. So various targets like water bodies, earth, vegetations, and forest area, and some barren lands. These are the targets. So after incident of the radiation, the reflectance value is different for different targets. So after receiving all this reflectance value, we create a satellite image that is based on uh, panchromatic or multispectral or any microwave satellite image. The recording of the energy sensors after recording of this reflectance, we calculate all these reflectance value, then it is recorded in the sensors. Then transmission, reception, and processing, these are the energy recorded by the sensor to be transmitted or of an electronic form, and receiving and processing different stations. Then interpretation and analysis. After receiving all these electromagnetic radiations, the image is interpreted visually or digitally or manually and extracts information about the target which is illuminated. Then application is the final element of the remote sensing process. It is achieved when you apply the information we have been able to extract from the imagery. So these are the history of remote sensing, the first aerial photograph from hot air balloon previously. These are the techniques which are used for uh, taking photograph from different elevations without in 1958, that is the uh, photograph of this area. So after that, the pigeon mounted camera were used in 19 uh, onwards, 1900 onwards. Then plane mounted cameras after 1914 and to 1945. Then up to 1947, there is a space-based photograph that is taken in March 1947. After that, the first Earth observation satellite that is called Landsat 1, which is launched in 1972. Then after that, various satellite images like Landsat 1, 2, 3, 4, then Spot image in 1986. So these are the very low spatial resolution data, and nowadays very high resolution data are available. So these are the Landsat missions in line Landsat 1, that is in 1972, Landsat 2 is 1975 to 1983. So basically one satellite have span over 10 to 15 years. After that, a new satellite is launched for that to collect the data. So in Landsat series, there is Landsat 1 to Landsat 9 up to 2020, uh, which has highest spatial resolution of 10-meter resolution. These are some ISRO missions, remote sensing satellites since 1988. IRS-1A, that is in 1988, USSR, the missions completed. Then IRS-1B, IRS-1C, and IRS-1D, IRS-P4 OceanSat used for only oceanography, and IRS-P6 research set, that is for optical remote sensing. Then IRS-P5 cartosat, that is panchromatic image, and panchromatic means that is a black and white image. Then cartosat 2 image, there is also medium resolution satellite image, and cartosat 2A OceanSat. These are the satellites which are launched by remote sensing, Indian remote sensing. Then one of the Chandrayaan mission was there in 2019 launched, where the three parts are there. That is orbiter, and one is lander, another is rover. So the three parts are there. So remote sensing advantages, and there are advantages and there are also a disadvantages are there. Synoptic view, or there's some advantages are synoptic view. So large area we can cover with the help of remote sensing technique. We can survey a larger area instead of field survey. Then it has also a global coverage. All the optical satellite image have coverage all the global area, totally all over the globe. Then repeatability is very much important. So some of the satellite images have a repeatability of 10 to 15 days of interval. Then multispectral sensor, that it is very much important for different application. So more than 3 to 4 sensors are used and different bands are used for different applications. So in hyperspectral image, more than 200 specular bands are used. For panchromatic, only one band, that is black and white image, is used for analysis of urban areas. Then multi-resolutions. One satellite image have different resolutions. One is 10-meter resolution, or another is 30-meter resolutions. So in Landsat, suppose in Sentinel 2 data, that is available of 30-meter resolution data and 10-meter resolution data of different bands. And near real-time data, so there's data are also available, like weather forecasting satellite, which are real-time data, and telecommunication satellites also have real-time data. And systematic data collection. So all the satellite images have different path and row. So it is collected in a different systematic way to cover all over the globe, and having the different row number and path number. The only solution sometimes for the otherwise inaccessible areas. So some areas which are not accessible for general survey, for field survey. So in these areas we can use the satellite image for suppose for earthquake or some in cloud mapping. So it is very much useful for this satellite image and real-time satellite image also. So generate data, the multi-purpose data set. So sometimes we use one satellite image for multiple times for different applications, or to use base map for different applications between different satellite data. हेलो. सो अभी तक जो भी कहा, थोड़ा सा आप जो भी आपने समझा, इसमें से कुछ डाउट है तो पूछ लीजिए, और डिफरेंट कुछ इससे रिलेटेड कुछ क्वेश्चन है तो पूछ लीजिए, उसके बाद आगे देखते हैं. हेलो. एनीवन? सुमित, नारायण, यू हैव एनी डाउट?
No, sir, no doubt.
तो आपने पहले कुछ किया था क्या, रिमोट सेंसिंग का क्लास?
Yes, sir.
क्या पहले क्या क्लास हुआ था?
Sir, ये introduction remote sensing का.
अच्छा, आपका बैकग्राउंड क्या है?
Sir, geography.
Everyone have geography or any other background is there?
सर मैं जनरली जॉब ये रिमोट सेंसिंग जीएस में कर रहा हूँ, पर मेरा बैकग्राउंड बी एल एल बी है सर, बी आर्ट्स।
अच्छा अच्छा।
जी
तो आप रिमोट सेंसिंग पहले पढ़े हैं या फर्स्ट टाइम?
सर, इसमें मेरा 16-17 साल का एक्सपीरियंस है सर ऑलरेडी में।
मतलब किस लाइन में?
सर मैं यहाँ पे अभी वाइल्ड लाइफ डिवीजन शासनगिर फॉरेस्ट डिपार्टमेंट में एज अ
हम्म।
जीएस एनालिस्ट जॉब कर रहा हूँ सर।
कहाँ पे?
गुजरात एशियाटिक लायन सेंचुरी में, गिर शासनगिर।
अच्छा 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 अच्छा।
जी
तो जनरली आप फॉरेस्ट डाइवर्जन हो गया क्या, एलिफेंट कॉरिडोर या?
हाँ सर, एशियाटिक लायंस, लेपर्ड, फिर बर्ड को टैगिंग किया हुआ है बहुत सारी स्पीसीज को, तो इसके रिलेटेड बहुत सारे साइंटिफिक एनालिसिस भी बहुत होता है सर।
तो उसमें क्या ज़्यादातर आप गूगल अर्थ यूज़ करते हैं?
नहीं सर, मेरे पास ये है ना सॉफ्टवेयर क्यूजीएस और ये
या
आरजीएस।
नहीं, सॉफ्टवेयर नहीं, सैटेलाइट इमेज।
सैटेलाइट इमेज में सर लैंडसैट है, फिर ये सेंटिनल इमेज में सारी चीज़।
हाँ, तो ज़्यादातर आप ओपन सोर्स सैटेलाइट इमेज यूज़ करते हैं।
यस यस सर।
ओके। तो ये आपका एमएससी है या पीजीडीसी है?
पीजीडीजी है सर।
अच्छा। देन अमित कुमार। आपका क्या बैकग्राउंड है अमित कुमार जी?
हेलो।
हाँ
आवाज़ आ
हेलो।
रही है सर?
हाँ हाँ बोलिए।
हाँ सर, मैं सीनियर ड्राफ्टमैन हूँ सेंट्रल वाटर कमीशन में।
अच्छा अच्छा।
हाँ, तो मेरा डैम डिजाइनिंग का और वो कैचमेंट एरिया उस सब में काम रहता है।
तो ज़्यादातर वाटर साइड वेस्ट काम होता है।
जी।
तो डैम डाटा कहाँ से लाते हैं, ऐसा टीम डाटा?
हाँ, डैम डाटा वगैरह वो सब तो हमें स्टेट से प्रोवाइड होता है सर।
अच्छा अच्छा। उसका कितना रेजोल्यूशन है?
हाँ, रेजोल्यूशन।
मतलब उसका स्पेशल रेजोल्यूशन डैम का आपका मतलब कौन सा डैम यूज़ करते हैं? कुछ एरियल सर्वे डैम डाटा और एनी डैम तो डाटा
एंटी
होगा ना?
कंटूर वगैरह जो डैम
अच्छा
और
कौन
उसके
सा?
आसपास कंटूर पे काम होता है सर।
अच्छा, जो सर्वे पे जो कंडक्ट हुआ है।
सर्वे पे, जी जी सर।
हम्म। तो बेसिकली आप ज़्यादातर वाटरशेड और
कैनाल और ये कैचमेंट
अच्छा, उसमें
इन सब
आप
पे।
आर्कजीएस यूज करते हैं शायद हाइड्रोलॉजी टूल में।
हाँ, नहीं अभी तो हम ऑटोकैड 3D और ये सिंपल यूज़ करते हैं। अभी ये नया सॉफ्टवेयर इसलिए तो सीखना है मुझे कि थोड़ा और मेरे लिए इनहेंस हो सके।
हाँ, आरजीएस सॉफ्टवेयर में है एक हाइड्रोलॉजी एक टूल है।
जी
तो
सर।
उसमें आपका डैम डाटा एनालिसिस ज़्यादातर होता है। ठीक है, देखते हैं। आप एक्चुअली मेरा क्लास आज नहीं था, तो मुझे अचानक करना पड़ा। मेरे जो कॉलेज है वो अभी अवेलेबल नहीं है।
Yes,
ओके। देन अमलराज जी। थैंक यू अमित।
ओके सर।
ओके। अमलराज, आप कहाँ से हैं? आई थिंक।
Yes, sir.
हाँ, आप बैकग्राउंड आपका क्या है?
So I'm completing MSc Geography.
ओके। फ्रॉम?
Tamil Nadu, sir. Central Institute
ओके।
of Tamil Nadu.
यू आर वर्किंग नाउ इन जेएस फील्ड और?
Yes, sir. I am working in junior map consultant in data science operation Tamil Nadu.
ओके ओके। यू आर यूजिंग डिफरेंट सॉफ्टवेयर आई थिंक इन जेएस सॉफ्टवेयर।
Yes, sir. QGS and RGS.
हर चीज ओके। ओके ओके। एंड सम Dishanto Dasgupta.
Sir, I have done MSc Geology.
From which university?
Sir, MSc Geology.
From which university?
Sir, Ranchi University.
Okay, okay. Then you are working any working professional or?
No, no, sir, not working.
Okay, okay. Then Yespal Singh Jala. Okay, Devin. Yespal Singh.
यस सर, मैंने बताया ना मैं सर गुजरात
अच्छा
जूनागढ़
अच्छा
डिस्ट्रिक्ट।
अच्छा 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 आपका है.
जी सर जी।
देन सुमित नारायण द्विवेदी.
Yes, sir.
आप कहाँ से हैं?
Sir, basically I belongs to Varanasi district of Uttar
अ,
Pradesh.
आपका क्वालिफिकेशन क्या है?
Sir, at present I am pursuing my PhD from IIPS Mumbai.
अच्छा, अभी पीएचडी कर रहे हैं.
Yes, sir.
जो इट इज रिमोट सेंसिंग बेस्ड और एनी अदर एप्लीकेशन.
No, sir, it's basically based on urbanization and aging process in India.
अच्छा अच्छा, urbanization. So urban sprawl also used
I
in
will
this.
try to look for, yes, yes, sir. That's why I choose this diploma course.
Okay, okay. So you try to use the Google Earth Engine platform for urban sprawl modeling, and different machine learning techniques are also there.
Okay, okay, sir.
So I'll provide you the link. Okay. So after completing some task, I will give you, because
Okay,
I have also completed 4 urban planning area previously.
okay, sir. Thank you, sir.
Okay. 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 Thank you. Then advantages of remote sensing, this processing and analysis is very fast. So all of you have known to the remote sensing and working in the different remote sensing applications. So these are some basics uh, slides are there as per the schedules, and after that some different techniques and image interpretation techniques are there. So the processing and then the advantages and the microwave remote sensing can penetrate cloud and dry sand. These are the high wavelength remote sensing techniques. So it can penetrate through the cloud. So during the uh, rainy season, we can collect the cloud-free data for the flood affected areas. So the flood management and fraud monitorings are very much useful for you using the microwave remote sensing satellites. So these satellites that are very uh, um, um, very big memory data, that is 100 to 200 GB data for each scene. So it requires different softwares which which could be handled for this. So it is not useful for ArcGIS softwares or AirDAS softwares. So optimize field investigations. So optimizing the field in investigation, like suppose you have pointed out some locations in the Google Earth engine, Google Earth software, then you have to go to the field and confirm this location. So for this purpose, we can use the remote sensing data. Then updating revision of existing map by using the different techniques, and color composite ensure the detail of the area. Different color image and infrared image, false color image, these are very much helpful for different applications. Suppose for mangrove application, we use generally infrared radiations, that is false color satellite image. In natural disaster studies also, it is very much useful, then overall cost effective. Then some disadvantages of the remote sensing technology. So remote sensing sometimes the unobstructive if the sensor passive record the EMR reflected emitted by the object of interest. Passive remote sensing does not disturb the object or area of interest. Remote sensing devices may be programmed to collect data systematically, such as within 10 kilometer frame of vertical aerial photography under controlled conditions. So these are the some advantages the remote sensing can provide fundamental informations including a latitude, longitude, and elevations, and biomass and temperature along with the moisture contents. So some limitations are there. That is greatest limitation is that the our soul, that is remote sensing, is not panacea that provide all this information needed to conduct physical, biological, or social science research. It provides some spatial, spectral, temporal information, some satellite image which are open source satellite image we cannot use for urban mapping because it is not as much as high resolution as compared to the commercial satellite image. So generally for urban applications we use 1 to 2 meter resolution satellites, but in open source that is not available. So these are the some drawback, and human beings select the appropriate remote sensing system to collect the data. So based on the technical expert, we can uh, use this map. So it is depend upon the expertise of the remote sensing expert, and how this is mapping is correct or not. So human method producer error may be the one of the contributor to the drawback of the remote sensing technology. Then the instrument and mission parameter are also one of the factor. Then according to the syllabus, that is I think principle of remote sensing, interaction of EMR, spectral properties. These are the contents. So these are the some definition which are provided in the book. Then history, that is different uh, discovery and theory which are written in the theory book. So you can read all these for the exam. Then properties of the EMR. So it is very much important for in the remote sensing technology the EMR, that is electromagnetic radiations properties. So for different object there is a different dielectric constant and different uh, physical and chemical properties. So uh, the wavelength of blue, green, red uh, give the different variation with the interaction of different object. Suppose in the water bodies, the radiation when incident into the water bodies, that is it is mostly absorb all these radiations, and less radiation is reflected back. So the water bodies look like dark tone, and for suppose for sand and other concrete area, the most of the radiations, blue, green, red radiations, are reflected back. So that is light, and that is the tone is very bright tone. So we can interpret all these landforms and different landforms with the help of the reflectance and absorbance properties of the electromagnetic radiations. So uh, green vegetations and different evergreen forest absorb most of the radiations. So this is the electromagnetic spectrums, that is electric and magnetic spectrum, that is perpendicular to each other, and all these radiations wavelength are given from lower to higher wavelength. Then Planck's radiations law are given. These are some examples. Then some interaction of EMR with Earth and atmospheres. What is refraction, scattering, absorption, reflection, transmission, radiant energy, radiant flux, and different radiance albedo. There are some structure. So reflectance, when some Earth object body is incident with the solar energy or any radiations, then it absorbs some of the energy, then it scatter back some energy, that is reflected energy. So with this reflected energy, the satellite sensor absorb all this reflected energy. So this energy converted into different different features in the satellite images. So spectral signature, most of the satellite images are 5 to 7 or 10, 10 to 10, 10 to 12 bands are there. So different bands show a different signature. For soil, it is different signature. For water bodies, it is different signature. If the water body is clear, then the signature is different. If the water bodies are polluted, then the signature is varied from the clear water. Then vegetations also it give the different signature. For green vegetation, the signature is different. For small group of trees, that the signature is different. So vegetation, water bodies, soil, and barren lands. So all these are give different signature for different bands. For blue bands, it is different. Then for infrared band, it is also different. But along with this, hyperspectral remote sensing technology is one of the technology where more than 200 bands are there. So in this, we can use the mineral exploration, which type of minerals are there with the help of the signature properties of the hyperspectral remote sensing images, uh, and also different chlorophyll pigment. It is reflected different wavelength. So the different species of the forest areas or in the mangrove areas, we can differentiate all the forest tree species with the help of the hyperspectral remote sensing along with the spectroradiometer field based survey. So this is the high level technology. Nowadays, no more satellite images are available for hyperspectral sensors. I think the Hyperion is widely used for hyperspectral remote sensing, and another I think I don't know the name, but is that is also high resolution hyperspectral sensor. Average data, I think that is a hyperspectral sensor. The spectral signature is the specific combination of reflected, absorbed, and transmitted emitted EMR by the object and varying of length, which can you can read all these documents which are provided with you. So for in example maximum, there is a question coming from the different what is that different wavelength of the mm, different color like blue, green, red, infrared, uh, and mid infrared, short wave infrared, then microwave. So you have to go through these, the different wavelength of different color bands, and what is the spatial resolution of different satellite, and what is the spectral resolution of different satellite. So these are asked in this examination. The soil moisture. So soil moisture is one of the factor which is very much mm, affected by the satellite image radiations. So if the soil moisture is high, then it looks like the dark tone. If the soil moisture is very less, it looks like the bright tone in the satellite image, either in the panchromatic satellite image or in the multispectral satellite image. So soil moisture content also map with the help of the different satellite image. Then effect of organic matter. Suppose there is a organic matter in the content of in the soil, then the reflectance also give in the different way. Then texture and structure of the soil also give the different reflectance. So after analysis of this reflectance characteristics, we can calculate, we can analyze the different landform and categorize according to them in the land cover map. What is barren land, or it is scrub land, or it is a wetland, or it is wasteland, or it is a sandy area. Depend upon the reflectance and the absorptance value and the texture and tone of the satellite images, we differentiate and categorize along according to them. So spectral signature of the water is also given in this book, so you can go through it. Then spectral signature of minerals and rocks. So spectral signature of minerals for calcite and quartzite and kaolinite, these are having different spectral signature. So to identify the minerals, we have to mm, take the spectral radiation curve information by this spectral radiometers. Then, with the help of the satellite image, we also match the spectral reflectance curve from the field and with the satellite image. Then we analyze, and if the two curves are matching each other, then we categorize it is a quartzite or it is a calcite or in other mineral. So it is only for hyperspectral image only. So other satellite image cannot categorize these minerals very effectively. So most of the previous discussions around the selection of specific spectral band of the given theme, the gray, dry grass and green grass. So in this graph, we will see that the green grass, that is absorption is very high, so it is reflectance is very low. Then dry gas, then clay matter is very high reflectance value. So when the chlorophyll pigment in the vegetation is very high, then reflectance value of the any remote sensing satellite sensor is very low. So chlorophyll pigment absorbs more of the spectrum, so the reflectance value is low and it looks like the very dark tone in the satellite image. Then image interpretation keys. So it will be taught in another section. basic principles and tone, texture, size, shape, texture, height, shadow association, pattern, side, tertiary, higher, secondary, primary. So primarily tone, color are very much important to identify the features of different features like whether it is a forest area or it is a road or a river or it is a dam. So it is a primary uh, basic principles. Then secondary, it is size. It is depend on the how suppose the river it is depend on the shape of the river. So texture generally depend upon the urban area. So in urban area the texture is different and the rural area it is texture is different. In tertiary, that is pattern. Suppose it is a plantation area, the pattern is different. And height, so height in sense of the buildings and the low lying area. So and shadow basically water tanks. So we can identify the water tanks with their shadow. Then associations, so association along with the different agriculture field along with some associated canals and pattern of the land is also categorized into different uh, agricultural activities like aquaculture or it is a horticultural or it is agricultural or it is some other activities. Then site, so for different coastal areas there is a different type of landform. For hilly terrain area that is a different type of landform. For estuarian area there is also different type of landform, and for Himalayan area that is also a different type of landform. Site defines different landforms. So these are some principles how to image interpretation taken care with the keys of this image interpretation key. So basically for this season, these are the uh, topics. So you can discuss if any doubt is there or any queries are there. Hello? Hmm. जी ଆପଣ ଯାଆନ୍ତୁ ମୁଁ ଯାଉଛି। Okay, so if you have any queries, then you can ask, or any discussion you need, then you can ask. Otherwise, we have to conclude this session. Anything else? Amit Kumar? Hello?
Hello, good evening, sir.
Good evening.
Sir, I and some other students joined after 6 o'clock, and
Okay.
we missed the first 17 or 18 slides, sir. If you
Okay.
can, in not in expand in briefly little bit about the every slide and little bit things about the first 17 slides.
First 17, no?
Yes, sir. Yes, sir. We joined at the 6 o'clock, and that time you were at the 17 or 18, I think so.
Okay, okay, okay. Okay, so this class is generally basics of remote sensing. Okay, so remote sensing is generally acquiring the information of an objects with the help of electromagnetic radiation with some distance to give the information for the different landform of the earth. So for giving all this information mm, for the remote sensing technique, some of the key elements which are used to acquire the data and acquiring the some information from the different objects is like energy source. So there is a need of energy source or illuminations. So without any energy source, we cannot use the successful uh, implantation of remote sensing. So for basically some energy source are the sun is one of the major energy source for radius electromagnetic radiation. Through this electromagnetic radiation, we absorbs which the earth absorbs some electromagnetic radiations and reflect back some radiation. So these reflected back radiations are absorbed by the satellite sensors. Then this data are contributing to the creation of different satellite images in different bands. So the energy source for there is so as of sun is a one of the energy source. Some of the sensor like microwave remote sensing is have own their illuminations. So these are the fact, and then the radiation, the atmosphere. The atmospheres play a major role for the remote sensing technique as different atmospheric parameters are there. So different layers are there. So radiations of this energy travel through all of the atmosphere. So atmospheric correction also needed for remote sensing data if that is deviated from the sources. So that is also an important factor. Then interaction with the target. Target means the different objects like vegetations, a river, and agricultural land, forest area, built up areas. All these are the targets for the remote sensing technology for this for useful for creation of image. So interaction with the target, then recording of energy by the sensor. After recording of this energy, it is recorded in the sensors, then transmission, reception, and processing. After processing all this recording, it is analyzed and interpreted. So after interpreted all these analysis, then it is prepared for different application. So after that, after completing all this analysis, this data are used in the GIS field. So this data, after completing the different remote sensing process, the GIS field is used after this complete process. So remote sensing and GIS are interrelated to each other. So remote sensing acquire the data, raw data, then process all this raw data in different bands for different applications. Then GIS application use this raw data for different projects, different applications. Then it is give different maps according to the requirement. So basics, the base, the remote sensing is the base for the GIS applications. So these are the interrelated applications, that is remote sensing and GIS. So some of the GIS softwares are helpful for remote sensing also, but some of the remote sensing softwares are not helpful for GIS application. So in this application, in the remote sensing technique, generally we use the three range of spectrum, that is visible region, another is infrared region, and another is microwave region. So these three regions have different spectral bands, and these are categorized in three different spectral bands based on the different applications. For forest mm, cover mapping, the visible region is very much helpful. For mangrove area calculations, water body calculation, infrared bands is useful, and for uh, earthquake mapping and flood area monitoring or calculating, microwave regions are there. So visible region has low wavelength data, then infrared region has higher than the visible region, then microwave, that is highest wavelength, which is used for the remote sensing. So if the wavelength is gradually higher, then penetrating capacity in the atmosphere is more higher, penetrating to the cloud is more higher. So in the monsoon season, the microwave data penetrating through the cloud and reaches to the earth and absorb and collect the cloud area cover data, and with the help of this data we can monitor all these flood affected areas. So microwave remote sensing is very complex techniques as compared to the infrared and visible region techniques. So most of the time the questions are arises. So which has the highest wavelength in the visible region or infrared region or microwave region? So you can uh, give all these answers with the help of this information. So you have to keep in mind that these are the uh, spectrums which are mostly useful for the satellite sensors. So out of this, there is no other sensors, other spectral bands are there for the use of the different satellite image. So all these different satellite image can have the information of different visible, infrared, and microwave. So we have used the Google Earth engine, sorry, Google Earth satellite image. So that is a visible region satellite image. So it has no infrared region satellite image, and microwave is very much costly satellite image. So it is only limited applications are there. Then present day remote sensing is has the different platforms. So different applications are gone through the different platform. There is ground based platform, which is antenna, and some of the tower is there. These are the ground-based platform. The small height related aerial television, UAV drone. These are the data which are very uh, less height. So after that, then airborne platform, which is limited to 4 to 5 kilometer above the earth. Then the spaceborne platform, that is 700 to 900 kilometer, which is built by the all the satellites are there. The satellites are in the very high uh, orbital region. So there is a airborne platform, a spaceborne platform, and a ground-based platform. So basically, we use all these Earth observation satellites like Google Earth software, other multispectral satellite image in the polar orbit from North Pole to South Pole, and other telecommunication satellites, geosynchronized satellites like weather forecasting satellites. These are the stationary, geostationary orbits. So there are two orbits are there. Then energy sources already given this image, and radiations, atmospheres, the interaction with the target, recording energy, transmissions. All these are in the image. Then aerial remote sensing history. The first aerial photograph from hot air balloon is 1958. Previously, there is no uh, any arrangement of the satellite image. There is no technique developed for the spaceball platform. So, in this era, um, air balloons are used for this taking photographs of the aerial view. Then fusion mounted camera, plane mounted camera. After that, uh, in the 1972, the launch of Landsat satellite is a complete satellite image is provided, uh, and after that, all the satellite having different resolution are started. So from 1972, all this launching of satellites and different applications are going. So this is the Landsat mission from Landsat 1 in 1972 to 2020 Landsat 9 satellite image. The difference span from 72 to 78. The different time span and longevity of the satellites are there. So like that, then Indian remote sensing satellites. These are the all ISRO missions, Indian remote sensing satellites. So they are from 1988 to onwards. All these satellites are there. So up to date, the Cartosat 2A, 2V, these are high resolution satellite which is available in India. Then Chandrayaan mission, uh, there is the three orbiter lander Vikram, rover Pragyan. These are the ingredients of the satellite which are land in the Chandrayaan 1 in July 2019. So advantages of the remote sensing technique is the synoptic view, global coverage, repeatability, multispectral sensor. We can measure energy, wavelength beyond the range of human vision, multi-resolution, near real-time, systematic data collection. The synoptic view means suppose we have to collect the data in the drone image, so it covers the very less aerial view as compared to the satellite image. So if satellite image covers more than 100 kilometers in a one span of time. And global coverage, it has the global coverage. Some of the satellite is global coverage, some of the satellite is for different local areas. Then repeatability, suppose for monsoon area we can use different satellite image, for winter area we also use a different satellite image. So we can change detection also, we can calculate with different seasons data. Then multispectral, it has also multispectral sensor, means multiple spectral bands are there, more than 5 6 bands are there, like blue range, green band, red band, infrared band, then short wave infrared, medium wave infrared, far wave infrared. These are the different sensors are used for different applications. Then multi resolutions, one satellite have 10-meter resolution data along with 30-meter resolution data based on their bands. Some bands, 4 5 bands have 10-meter, then 8 9 bands are 30-meter resolutions. So near real-time data, suppose telecommunication satellites and weather forecasting satellite, these are the real-time data. We can calculate uh, the weather analysis with the help of the uh, data of the climate data. The systematic data collection, the satellite data collect the data with systematic way in the row and column wise in tile format, different tile format. So we can collect the data for different use and different applications. The only solution sometimes for the otherwise inaccessible areas. Suppose for non-accessible areas, we can use satellite image to analyze this data. Then generic data multi-purpose we can use for any satellite image for urban mapping, and same data we can use for flood analysis. Same data can be used for land use land cover mapping. Same data can be used for road and network mapping, and also vegetation mapping. So multiple uses are there for single satellite images based on their bands available. Then processing analysis is fast as compared to the other techniques. Microwave wave remote sensing, which is penetrate cloud, which is already discussed. Then optimize field investigation. Suppose we have the field wave data, then we can optimize this data with the help of the field data and the satellite image data. Then updating existing maps by other data with faster ways. Color composite, having the real-time color data. In natural disaster studies, rescue missions, we can use this satellite image and monitoring purpose. Overall cost effective. All of these data which are available in the open source, which is very cost effective, and we can use for the different research and different project or the different applications. Then remote sensing also the possible record the EMR reflected emitted the object of the interest, and also device by the program to collect data systematically, such as within 10 to 10 kilometer frame or 20 to 20 kilometer frame. Under control condition, remote sensing also provide fundamental biophysical information, latitude, longitude information, along with elevation information, bathymetry information, biomass, temperature, and moisture content. These are the mm, parameters we can calculate it with the help of remote sensing data. Then remote sensing has some of the limitation is there. It is not a panacea that provide all the information needed to conduct. Sometimes we need very high resolution data for particular purpose, but we cannot find this data for a particular time. But in low resolution data it is available, but it is not suitable for different applications. And some of the maps which are prepared by the different experts may have some interpretations lacking of less interpretation skills, which have some errors, and with the satellite data which have some accuracy errors. Cloud free data is not available in all the times. uh, some data which are optical data which are not cloud free in the monsoon season, so this is also very much obstacle for acquiring data. And different methods technology also may have some error to calculate the accuracy of the data. So some of the remote sensing limitations are there, but overall, for overall analysis, quick uh, decision and monitoring, it is very much helpful as compared to the other technology. Okay, your 17 slides are completed.
Yes, sir. Okay, sir. Thank you, sir.
Thank you. So we have to uh, end this session. If any have any no queries
सर
is
वो,
there.
हेलो सर,
हाँ कौन सा?
सर वो गूगल अर्थ इंजन वाला सर आप शेयर करेंगे प्लीज सर, बता देंगे।
अभी तो पॉसिबल नहीं है। एक्चुअली मैं ऑफिस में ही हूँ।
ओके सर।
एक सीजन अगर मेरा एक्चुअली ये मेरा क्लास नहीं है। जब मेरा स्टार्ट हो जाएगा तो गूगल अर्थ में कैसे एक्सट्रैक्ट करते हैं डिफरेंट डाटा मैं
यस
बता दूंगा। ओके,
क्योंकि सर
तो
मेरे
इसके लिए
जी
तो गूगल अर्थ इंजन में क्या है कि आपको थोड़ा रिमोट सेंसिंग का बेसिक जानना चाहिए कि आपको सपोज डिफरेंट एप्लीकेशन के लिए कौन सा सैटेलाइट चाहिए, कौन
जी सर।
सैटेलाइट इमेज कौन सा बैंड्स चाहिए।
जी
आपका कौन
सर।
सा एप्लीकेशन है?
सर मतलब कौन सा सॉफ्टवेयर?
नहीं नहीं, एप्लीकेशन काम क्या है?
काम में सर मेरा नेक्स्ट ईयर लाइन सेंसस है 2025 में, तो उसके लिए लैंड यूज लैंड कवर और वो सब कौन सा हैबिटेट लाइन यूज करते हैं वो उसके लिए सर एक थोड़ा एनालिसिस करना था
हाँ, उसमें तो हो जाएगा लैंड यूज लैंड कवर बायोमास
सर।
एस्टिमेशन।
चेंज डिटेक्शन का करना था सर मुझे
हाँ, चेंज भी हो जाएगा,
लास्ट 10 ईयर का।
लेकिन फास्ट 10 ईयर्स का। ओके,
जी
तो उसमें आपको एक आईडी खोलना पड़ेगा गूगल
सर,
अर्थ
वो
में।
ऑलरेडी बहुत सारा फॉर्मेलिटीज मैंने कर दिया है, पर वो कोडिंग और वो सब थोड़ा होता है तो वो थोड़ा सर कॉम्प्लिकेशन है।
ओके ओके, मैं कोडिंग अगर मैं कर दूंगा कोडिंग आपके एरिया का
ओके
कि
सर।
नहीं तो एक एग्जांपल ले जाएंगे। वो कोडिंग आप पेस्ट कर देंगे तो उस कोडिंग से आपको थोड़ा सा एडिट करने के बाद वो हो जाएगा।
ओके सर जी, थैंक यू
ठीक है,
सर।
देखेंगे, अभी तो टाइम है, 1 मंथ अदर है, तो उसमें थोड़ा गूगल अर्थ इंजन भी देख लेंगे, और जो भी है जेएस थोड़ा सा एप्लीकेशन।
सर
ओके,
ये
हम्म।
प्रेजेंटेशन भी शेयर हो सकता है सर, पॉसिबल?
हाँ, अभी इसको मैं पीडीएफ करके सेंड कर दूंगा। और कहाँ पे करूँगा ये सब हमारा?
सर एक ये व्हाट्सएप ग्रुप बनाया हुआ है इसमें सर, इसका
सर राकेश सर, राकेश सर एक ग्रुप में ऐड हैं। सर आप उनको शेयर कर दीजिएगा, वो शेयर कर देंगे।
अच्छा हाँ, वो उसमें मैं शेयर कर
या
दूंगा।
तो सर को भी ऐड कर सकते हैं, बलविंदर सिंह।
हाँ जी सर, आप सर आपको भी एक्चुअली मैं एडमिन नहीं हूँ। एडमिन इज रितिका भाटिया।
अच्छा, पीजीडीसी बीजीआई 2020 ना?
ये 2024, यस सर।
अच्छा, 2024 का है।
जी
ठीक है,
सर।
मैं इसमें भेज दूंगा।
ठीक है सर।
ओके ओके, then we have to conclude this session, or any doubt?
नो सर, थैंक यू।
नो सर, थैंक यू सर।
Okay, thank you. ପଳେଇଲେ ସବୁ ହଁ ପଳେଇବା ସାଙ୍ଗେ ସାଙ୍ଗେ ଆଉ 2 ମିନିଟ୍ କବାଟ ବନ୍ଦ କରିବ ଯିବା ଆଉ। ଆଜି କଣ ଏତେ ଜଲ୍ଦି ପଳେଇଲେ? କଣ କହିଲୁ ଆଜି ପଳେଇଲେ କଣ ହବ ସବୁଦିନ ଗଲେ ସିନା ଦରମା ତ ବଢୁନି। ଡାଇରେକ୍ଟରକୁ ଆସିଲେ ଏଥର କହିବ ନା ନାଇଁ? ଡାଇରେକ୍ଟରକୁ ଆସିଲେ କହିବ ନା ନାଇଁ? हाँ भाई कोडी আচ্ছা আচ্ছা কথা বলছেন হুম ହଁ ହ୍ୟାଲୋ ନମସ୍କାର କଣ କରୁଥିଲ ଘରକୁ କିଏ ଆସିଛନ୍ତି ପରା ଗେଷ୍ଟ ବସିଥିଲ